do today is we want to create a set of data for a fictitious election. All right, so what we're going to do, I want to look at somewhere in here we documented this stuff, didn't we? Doesn't really matter. I thought we did though. Didn't we have a what inputs and outputs mean? Oh, here it is. So we're going to create our own JSON data that's similar to what the components of blockchain.info's data looks like, simulating our own election. So outs is the recipients of a transaction, inputs is the sender of the transaction. So in our little world here, we are going to have a bunch of voting sources. Bunch of voting sources. Where a voting source can be a public computer. So there can be election polls, if you will, where people all come and send their vote from one place. It can be their home computer, so it can come from that source. So on and so forth. So we're going to have a bunch of sources for our votes. Those are going to go into the inputs. Okay, so we're going to have a big JSON document that is going to have a collection of transactions. Those transactions are going to be all of the transactions that ended up in this particular wallet, where each candidate has their own sub-wallet address. Okay, so we're going to have a bunch of voting sources where the sources are stored in outs. Are stored in inputs. We're going to have two separate candidates that can receive votes. These are stored in outs. Outs may also contain votes or I'm going to call them votes. Actually, let's not call them votes. Let's call them payments to non-candidates. All right. Since we're using a Bitcoin wallet or a cryptocurrency wallet for this, when we look at a particular transaction, somebody could have sent 5 Bitcoins to one of our wallets, one of our sub-wallets that wasn't a sub-wallet associated with a candidate. Okay, so for instance, in our Bitcoin wallet, we might say we have candidate A, candidate B, Christmas fund, some things like that. So only 2 of our sub-addresses are going to be addresses that we are interested in as far as votes. All right, but we're going to go ahead and create a scenario where we might have 5 total addresses. Okay.
What do you do about write-in candidates?
That doesn't exist in this little scenario. But in a more completely done scenario, it would. But in this scenario, I'm basically giving you a simpler data structure to parse for a homework assignment. It's essentially what we're working towards here. So we're going to have 5 total wallet addresses that can receive payments, only 2 of which are dedicated to candidates. Okay? So we're only interested in counting the votes associated with those candidates. So we want to create some code that generates a random document, a random JSON document simulating a vote. Okay? So we're going to jump into Eclipse here. Let me shut all of this stuff. So for right now, what I'm going to do is I'm going to create a new class called ElectionGenerator. Okay, and ElectionGenerator is going to take in an integer number of candidates. Well, I don't know what I was doing there. Num candidates and num wallets. Actually, for us, for this example, we'll just assume those are 2 and 5. So we won't even take them in as parameters. So 2 candidates, 5 unique wallet addresses. Okay, now we know that our JSON should look something like, let's just go here. Was it TXS like that?
Yeah.
Here, I'll kick this down so it's a little bit more readable. Oh, and actually, I'm missing something here. So this would be when there's 3 transactions, just as a little example. All right, so inputs is who sent it. So this would be let's actually do this. This would be a list of senders. So let's say ABC actually we just say address ABC DEF, something like that. Okay, so for inputs for this first transaction, we might have 2 addresses. This is where the transaction came from, just like blockchain info's thing had. Realistically for us, we can assume they all have a single transaction in them. Won't make a difference. It's still going to be an array of transactions. That's the important thing here. So if it makes you feel better, we can depict it as a single address from the sender, but it's still inside of an array. The outputs is going to be all the places that that address sent payments to, okay, including ours. All right, so inside here, it's going to be address, colon, amount, comma, address, colon, amount, something like that, so on and so forth. So this could be a whole collection of recipients.
You're not supposed to have quotations under the amount.
Yeah, you are.
Otherwise that would be dumb.
That's true. Okay. And then these other ones down here would be similar to those. And here I can actually just copy this. It's for a single transaction. There's another transaction. There's another transaction. Something along those lines. Okay? So what we're looking at doing is generating a random document like this that we can then go and parse for to come up with how many votes an election had. Kind of a proof of concept. Since now we know what the data that comes out of blockchain.info looks like. So we want to write a program that randomly builds a JSON document like this. Okay? So we're going to have random sources. So for the address, for the inputs side of this, we'll have an array and we'll just fill it with one address, like we have there. So kind of stupid to have an array, but that is how it's represented in blockchain.info. So we'll store it as an array. And those will be the source. So if we have 1,000 voters, okay, or 1,000 votes that were cast, we might have 1,000 unique from addresses, but we might also have 200 unique from addresses. Maybe a bunch of people voted at home, and then you had a big group of people that voted from a centralized voting place. Okay, so you might have 100 votes all come from one address. And that doesn't mean they're illegal. It just means that they were from a specific address. So you might have to take advantage of the notes or something. But for this, we're just going to assume it's okay. You know, that we used one wallet for a bunch of people to send it. So more of a proof of concept thing. Okay, so we'll randomly generate source addresses, or actually inputs, randomly generate source addresses. And then we want to randomly generate destination addresses with we want to fill it with a bunch of destination addresses, but make sure that one of them is one of our addresses. Does that make sense? Okay, because we're going to have to do that second tier of when we go through the outs. Remember, the outs is a big list of all transactions that occurred that added up to a final value or something like that. Well, in that big list, remember last time we were looking, we can find ourselves somewhere in that list. Okay, so we want to make sure that our address, one of our 5 addresses, shows up in that list once, exactly once. But the rest of the list is filled up with a whole bunch of other addresses, faking us out, giving us something that we have to ignore in our parsing. Does that make sense? Okay. The value that's in there really is inconsequential. So we'll just make all the values 1,000 or something like that. Just, we're not going to, for our example, we're not going to look at, only 0.01 Bitcoin counts or something like that. We're just looking for total number of votes paid to different addresses. All right. So we know that our code always starts off like this and always ends like this. So we can actually start by generating that aspect of the JSON. Okay, so up top here, we're going to say private string, the JSON. This dot the JSON is equal to opening curly brace, followed by TX, so TXS, like that, followed by, and we're going to backspace those things, okay, followed by a colon, followed by a square bracket. Okay, so the JSON will start off like that. At the very end, the JSON will end with that followed by that. So we're kind of building a sandwich. If that makes sense. So everything in the middle here needs to be the act of filling that up with a bunch of objects. Okay? So we're going to have some private methods down here. Private string gen transaction object. And what this method is going to do is it's going to generate one of those guys. Actually, one of those guys. Copy that here. Paste it in here for us to look at. All right. So it's going to create a JSON object with an array of outs, where that array of outs is randomly filled up with stuff. Okay? Now, what we're going to do is, like I said, we're going to have 5 addresses. So we're going to have a private string array called R addresses. This dot R addresses is equal to a new string array of size 5. Okay. Now, what we're going to do is we're going to fill this up with the unique addresses that are our 5 wallets. But for our own sanity, what we'll do is we'll actually name them like words. It just happened to be that the hash came out to be something that's readable. Okay? So, we're going to say this dot R addresses at bucket 0 is equal to candidate 1. That's the unique hash for that wallet. Candidate 2, and I'll change the indexes here in a second. Birthday. Slush fund. And censored. Okay. So all we've done here is generated our 5 legitimate that belong to the destination wallet for this election. Okay, so I'll move this comment up here. So as we see here, 2 of these are actual candidates. The other 3 are not candidates. So anything that was paid to these 3 addresses, we don't want to count as votes. That make sense? All right. Now, our JSON will always start off like this. we have a variable called transactions, and that guy's going to be an array of transactions. That's why we're writing this gen transaction object down here. So what we might do is we might say generate, let's start off with 10 random transactions. Once we have this tested, we'll generate more than 10, but actually, you know what? Just so we can read it, let's generate 3 random transactions. So for int I is equal to 0, I is less than 3, I plus plus. Each time through, we're going to call our gen transaction object, which is going to do whatever magic is required to generate a transaction in this format. And what are we going to do? We're going to tack that on to the JSON. Okay? So we're going to say this dot the JSON plus equals. Now, the very first time we go through here, we don't want to have a comma. So we're going to say if I is equal to 0, then this dot the JSON is equal to, or plus equals, this dot gen transaction. Else, if this is not our first time through here, we need to have a comma followed by the object. Well, here, this would be the, actually, hold on. Yes, yeah, we're right here. So this guy is a single transaction. The second transaction that we would generate will have to have a comma in front. This is going to be transaction, comma, transaction, comma, transaction, comma, transaction. Make sense? So only the very first one doesn't have that comma in front. All the rest of them will have this dot the JSON plus equals a comma concatenated with this dot gen transaction object. So this will get us 3, in this case, transaction objects, assuming this guy works. Put them in between the opening square bracket and the closing square bracket, separated by commas. All right? And that should build our sandwich, assuming that we write gen transaction object correctly. All right. Now, for every single transaction that we're generating here, every transaction that we're generating, the destination will include a whole bunch of destination, so outs will include a whole bunch of addresses, exactly one of which will be one of our addresses. Some of them for candidates, some of them not. Okay? So we're going to need to determine which of our addresses go in there. So we'll say random r is equal to new random, import java.util.random. So now we have the ability to generate a random number. Now we want to get our address. So we're going to say string our address is going to be equal to this dot our addresses at bucket r dot nextInt 5. So this is going to give us a number between 0 and 4 inclusive, which just happens to coincide with one of our 5 buckets of our array. So each time we call gen transaction object, we will randomly determine which of our 5 addresses this transaction encompasses. Make sense? All right, so right after this line, we know what address that we're going to hide inside of the outs here. The rest of the addresses that go inside the outs are going to be random addresses. Now, because we've made all of our addresses up here contain letters, we can guarantee that if we just generate random numbers as our other addresses, that we won't accidentally generate a hash that happens to say candidate 1. Does that make sense? So we're going to have a bunch of random numbers looking like false addresses, addresses that we're not interested in counting, followed by just our address, the one that we picked. Okay? And what we're going to say, let's see where we at here. So we know our address is going to be somewhere in there. Okay, but we don't necessarily know where we're going to put it in there. Remember, the out is going to be a list of destination addresses, exactly one of which will be our address. Okay? So I'm going to generate 2 numbers. Num before is going to be r dot next int, let's say 20. Num after will be r dot next int 20. So we will have between 0 and 19 addresses that will come before our address, and between 0 and 19 addresses that will come after our address. So we're going to go through and we need to build this guy, padding it with our outs. So we're going to go ahead and let's create our string. Let's go down one line here. String JSON is equal to the string opening curly brace, outs, colon, open square bracket, okay, that's it for now for that guy. And eventually, JSON will be equal to the closing square bracket, followed by our inputs, followed by more stuff. Okay, closing square bracket, comma, inputs, colon, opening square bracket. So inside here, we're going to generate our outs. Well, thank you. Just testing you. And this is generate our inputs. And then finally, we're going to have JSON plus equals. So after inputs, we're going to have our final closing square bracket and our closing curly brace. Okay, so we have a kind of a double-decker sandwich here. So remember, the whole purpose of gen transaction object is to produce a string that looks like this. So it's always going to start off with an opening curly brace, followed by outs, followed by an opening square bracket. Inside of there, it'll be a whole bunch of these guys. So we're going to have to generate a bunch of random guys that look like that. Okay? Where we have 0 to 19 of those before we create one that has our address in it, followed by 0 to 19 of those, with commas after the ones after the first. Okay, so let's go ahead and generate our outs. Kick that down a line. For int I is equal to 0, I is less than num before I plus plus. So this is going to generate all of our addresses that should happen beforehand. Just to make sure this will make life a little bit easier for us, so we don't have to check to see if there was anything added. We'll make sure there's at least one address that comes beforehand. That way we can do the trick with the comma. Otherwise, we might get 0 addresses that come before, and then we tack on a comma before the future ones. So we don't. That's going to make it life harder. So we know that none before will at least be one random address. So our address will never be first in the list in this little example. So now we'll go through here. If I is equal to 0, no comma, else we'll have a comma. And what are we generating in here? These are going to be the random addresses that come before. So that's going to be something that looks like this, followed by address, so some address, followed by a value. And we'll just hard code all values to be 1,000. Okay? So we'll create a string temp address, or here, let's say temp object for this loop. Temp object will start off with a opening curly brace, followed by a double quote. So that's the backslash double quote, so it's treated as a double quote. Followed by a random address. So we're going to do random addresses as positive numbers. Make sense? So what we'll do is, just so we have kind of big looking values, I'll concatenate onto this. Oops. Math.abs. Oh, actually, this is. Well, it'll be fine. So we'll concatenate on the absolute value of our r.nextInt. So r.nextInt generates a number between -2 billion and positive 2 billion. Take the absolute value of that. So negative numbers become positive numbers. Or actually, we could just say generate a number between 0 and 200,000, 2 million, 20 million. Whoa, held that down too long. 2 million, 20 million.
Too long. You wanted to go back.
This is fine. We just need to be random numbers. Yeah, this is fine. Don't need to overthink this. So the address is going to be just some number between 0 and, what is this, 20 million?
Yeah, I think so.
0 and 20 million. That's the unique address. 0 and 20 million. Okay, guaranteeing it's not going to be one of these guys. We won't accidentally generate one of our addresses. Okay? So we'll have a opening curly brace, followed by double quote, followed by a random address, followed by a double quote, followed by a colon, followed by a double quote, we're always just going to have it be 1,000 because we're not going to count the number of votes, followed by a double quote, followed by a closing curly brace. So that's what temp object will look like. If temp object, if I is equal to 0, temp object will look exactly like that. So no comma. Else, temp object will look almost like that. It'll have a comma before it, because it's not the first address we're adding. Okay? Then, what are we doing with temp object? We're adding it onto our JSON. So JSON plus equals temp object. Okay? Similarly, we'll do this exact same, well, almost this exact same code for num after, except we don't need this equal 0 part because we know it's not going to be the first one, so we know it always has to have the comma before it. So this is addresses after. This is addresses before. And then in the middle here, we need to generate the address associated with our address, which is going to look just like this. Except instead of a random number, this will be our address. And then tack it onto JSON. So again, building our sandwich, between 1 and 20 before addresses, followed by our address, followed by between 0 and 19 addresses. Finally, followed by a closing square bracket and a closing curly brace. So this will generate a bunch of transactions for our outs. Well, actually, a bunch of transactions, yeah, just for our outs. Then we need to generate our inputs. Well, what's inputs going to look like? These are coming from all sorts of random addresses somewhere. We decided that for our example, inputs will still be an array, but it's only going to contain one address. So it's going to look like this. The random address that it's coming from is just not going to be from one of ours, so some number between 0 and 20 million. We can have an amount. The amount we'll just say is 1,000. We're not doing the math with it, so that technically wouldn't be right. It would be something like 27 bitcoins, and then all the addresses and out should add up to that, but it doesn't matter since we're not using the numbers. So here we'll say it's 100,000, just so it looks a little different. 500,000. Now it definitely looks different. So that's going to be our output address. We'll say JSON plus equals that. And then close our input. And then close our object. Ultimately, return JSON. Okay? So all this code does, figures out which of our 5 addresses we're going to randomly insert once. How many random addresses do we put before that guy? How many random addresses do we put after that guy? We build our JSON with the hard-coded what always comes before. Then we generate all the addresses that come beforehand, with the very first one not having a comma before it, but all the rest of them do have a comma before it. Then we tack on our address, so whatever our address ended up being, that transaction in outs. Then we add in all the addresses that come after ours. Then we move on to the inputs. So we close out the array of outs, move on to our array of inputs. Inputs has exactly one object in it. So we create that one object from some random address that's not ourselves. Tack it onto our JSON, close the inputs, close the object, return the object. Okay, so this method should generate a transaction object. So up here, I'm going to move this down below. We have our 5 addresses total. 2 of them are candidates, the other 3 are non-candidates. We're going to start off our JSON that we're creating with an object with a variable name txs, followed by the opening for an array. In this particular case, we're going to only generate 3 random transactions from our gen transaction object. So I equals 0, I is less than 3. If it's the very first time through, the transaction we tack on will not have a comma in front of it. Otherwise, we'll have a comma in front of that transaction. Keep going over and over and over until we hit the end. Close off our array of transactions, close off our object. So when all is said and done, we should be able to println this dot the JSON. And we should see something that looks like the correct code. So I'm going to go ahead and comment out all of this crap in here for right now. And what we're going to do is we're going to create an election generator, e.g. is equal to a new election generator. And at this point, everything happens in that constructor. And what we should see is an object that meets our criteria that we defined here with 3 transactions in it, where each of those transactions has up to 41 entries in outs and exactly 1 entry in inputs. Let's just make sure the format looks reasonable. So transactions, opening, array. Here's our outs, opening array. Here's the first out. Here's the second out, third out. So we only had 3 there. There's our slush fund hidden in there. 4th out, 5th, 6th, 7th, 8th, 9th, 10th. Keep going until we hit inputs. So there's the end of our outs array, comma, here's the beginning of inputs, beginning of the inputs array. So here's the single address that was the source of this payment. Closing that array, close that transaction, and then here's our next transaction object. All the way at the very end, we get our final input. Close that transaction. This closes our, this closes the array of inputs. This closes that last transaction. This closes our array of transactions, and then this closes our JSON object. That makes sense? All right. So now that we've written that code, we have the ability to generate 3,000 transactions if we want. This starts representing a major election type thing. Okay, so now what we'll do at the beginning of class next time is we're going to write this out to a file and then deal with reading it in from a file. And then your homework assignment, so if you want to start with the homework assignment, you can. The homework assignment is going to be, which I'll assign on Monday, to take this JSON, read it in from a file, process it, and ultimately give the results of the election in terms of which candidates between candidate 1 and candidate 2 got the most votes. So display the number of votes for candidate 1 and the number of votes for candidate 2 by parsing through all the JSON. Ignoring all addresses and outs that were not one of our addresses. And also ignoring all addresses and outs that weren't either candidate 1 or candidate 2. Make sense? Okay. So I'll give you a little bit more code on Monday, but if you did want to start with this, you could. But I don't think it'll take that long once you have the reading in from the file code. So I'll see everybody on Monday.